Okay, again, my name is Vladimir. I'm working for a Russian company called Elkomsoft. We have about 20 people in our team, and we are working for 20 years. And last 15 years, all we are doing is developing the software for password cracking and password recovery. And for last 3 or 4 years, we're also doing some mobile forensics, concentrating mainly on the Apple iPhones. And now we also have some research and some software for Blackberries. Obviously, you know that that platform is dying. And also something for Windows Phone. Now I'll tell you about the Windows iPhone forensics and also some stuff about Blackberries. I don't think I need to tell too much about the importance of the mobile device forensics, because mobile devices and smartphones and tablets are so widely used, and they contain a lot of critical and business information, your emails, contacts, credit card numbers, and whatever. And for different platforms, I'm missing actually Android there. There are a lot of people asking us about why we don't do anything for Android. Simply because we don't like it too much. We prefer to do what we actually love to do. And there are different methods to acquire information from the smartphones. The simplest way is to get the logical acquisition. It's usually either the backup or just using some protocol to communicate between the host PC or Mac and the smartphone. And there are some commands to get information out of there. There is also so-called advanced logical. I'll explain it further in my presentation. It is currently available only for Windows iPhones. Oh, sorry, for Apple iPhones and iPad as well. And it can get more information than with logical. There is also physical, when you create an image of the device. It is not available for Windows Phone and for Blackberry, and it is really hard to do for Windows iPhone, but it is also possible. The chip-off method, it is destructive method, and you have to disassemble the phone, get the memory chip out of there, and create a complete memory image for it. Currently, it is available only for all the Blackberry models and also for some smartphones made by Chinese manufacturers. In many cases, this is the only way to get information out of the smartphones. And probably the most interesting part is getting information from the cloud. Cloud is more and more widely used for the smartphones, mostly for Apple, but there is also something for Windows phones and for Android. And for Apple devices, Icloud is being used for backups, if of course you have set an option to use it. And you can also store the documents in the cloud. And there is also the location service when the cloud keeps the position of your smartphone, and it can also send a push request to your smartphone and to detect your current position. So mainly I will concentrate on the OS forensics. To make the logical acquisition of the information from the iPhone, you just have to ask the device to produce the backup. Backup is being produced not by iTunes, but actually by the iPhone itself. There is a special service running on the iPhone, which using the special commands being sent by USB. Produce the backup and just sends the blocks of information to the host machine. And if you set an option to encrypt the backup, all the encryption is being done on the device itself, not on the host computer, and so you get the encrypted data. But not backup contains only a limited amount of information. There are some things that don't go to the backup: music, videos, some settings, some of the application data, error logs, and so on. With the physical acquisition, to create the complete image of the iPhone, it is much harder to do. For iPhone 4 and older devices, there was a boot ROM vulnerability and so the jailbreak, and so you have been able to create a complete image of the iPhone even without the knowledge of the passcode. And it doesn't matter how long and complex the passcode is, we can still get an image of the iPhone, and some of the information in this image, it still remains encrypted because the encryption keys rely on the passcode, but most of the information is available in the plain text form. For iPhone 4S and later devices, it's much harder to do. There is no boot ROM vulnerability, there is only user-level jailbreak, and if the jailbreak is installed, we can still create a full physical image of the iPhone. Someone asking is, why do you have to perform the physical acquisition of the jailbroken iPhone if with a jailbreak you can get almost everything from the iPhone, but not everything. The exact image of the iPhone is much better than what you can get with the logical. For the advanced logical acquisition, it's not a widely popular method, but it is still being used by some forensic people. It's better to have the jailbreak installed as well, but even without it, you can connect to some services running on the iPhone and send the commands to get information out of there. I will also tell in details what's going on. And for to access the iCloud and get information out of there, of course, you need to get the Apple ID and the password to access the iCloud. And the main profit of this method is you don't need to have access to the device itself. You only need to know the Apple ID and password. And iCloud Backup, if you have an option set to create backups there, contains almost the same information as a local backup created by the iTunes. And also there is extensive storage that is being used for documents, and not only the Apple way to keep the Iwork documents, pages, keynote and numbers, but also cloud is being used by many applications, and now more and more are being used for passwords, for some specific applications, data, games, and whatever, some navigation systems. That's all. What is inside backup? I will go briefly through that. That's of course all your messages, contacts, both SMS and iMessage, pictures, all the videos, and so on. To create a local backup, you just start the iTunes and select the device and say create backup. For iCloud backups, you can set the iPhone to make iCloud backups automatically, and they're being done every 24 hours when the device is connected to Wi-Fi network and to the power source and locked. And you can also force creating the backup by just pressing a button, and you only need to be connected to the Wi-Fi. I have no idea why the iCloud backups cannot be created over the wired connection. And to browse information in the iTunes backup, you have to use a third-party software. Here is one of them. It is quite cheap and made by some Chinese developer, but I like it and I use it personally from time to time, and you have everything in the convenient form. If you have a look at the iTunes backup folder, you will see nothing but just a single folder with thousands or tens of thousands files with unreadable names. In fact, the name of the file is just an MD5 checksum of the actual file name as it appears in the iPhone file system, and you won't be able to read it and to see the contents. But using that software, or probably more advanced software, you can. But there is more actually in the iPhone backup than you think. There is, of course, the data of all applications. For example, all social network applications, Twitter, Facebook, WhatsApp, and so on. And there is a lot of other interesting stuff. For example, almost everything you enter on the iPhone keyboard is being stored in a special database. And for different languages, for example, I am obviously using both Russian and English in my conversations. And I have found two separate databases for English and for Russian with most of the words I have typed in SMS messages and notes and whatever. You have the data of the passbook, so your boarding passes, discount cards, and so on. You have a voicemail, and you have the map data, the caches of your searches, and the Google Maps, and the Apple Maps, and so on. There are also a special folder with message attachments when you are sending or receiving the pictures by the iMessage. And the funny thing is that if you delete the conversation from the iPhone, the attachments, the pictures are still being stored in the iPhone. I have deleted a lot of conversations from my phone. I had about 70,000 messages for last 2 years. And then when I analyzed my backup, I found the messages, or the pictures, sorry, that were attached to the messages about 2 years ago, and I was really surprised from the people I don't talk to anymore. There are also pictures from the cached pictures from the Twitter posts from Facebook posts and so on. And there is a lot of other data lost, like last backup date and time, and information of all Wi-Fi access points you ever connected to. And also, by the way, you cannot delete the information about those Wi-Fi points from your iPhone easily. You can, if you are connected to the Wi-Fi access point, you can press a button to forget this network. That's simple. But if you cannot connect to it now, the information on this access point is still stored in the iPhone. It is now with iOS 7, it's also information called frequent locations. It is an option to enable it, and it is enabled by default. It's hidden very deep inside, and most of the people I talked to didn't ever know that such option is available. It is under the privacy, location services, system services, and the frequent location. It collects information about your locations for last 40 days exactly, when you then all the information is being deleted, and there are records with almost exact time when you have been there, and it is quite a large database. You can see that, and somehow the device detects where is my home. I didn't set up the home address, but it still knows when I was there. And also some of this information is being sent to Apple, as you can see with the Improve Maps option. And so I have no idea how it is being used. And actually, it's probably for traffic or maybe for something else. So just be careful. Here is the database with location services data. There are different tables for Wi-Fi access points, for GSM, for LTE, and for yeah.
I think it's funny that this folder particularly was called, I think, Encrypted.
Yeah. It contains in the file name, it is a word encrypted. I think it is, it is, as you can see, cache encrypted A at the left side. But nothing is encrypted there, it is in a plain text form. And there are allocations of all those, of the access points, of the GSM and LTE cells. And also the time when you appeared in the area where this point is available and when you left it. Yeah, about the charges, you probably heard about the presentation made about a year ago on the Black Hat. Proof of concept, a very small computer based on a Beagle board, and it looks like a charger, but when you connect your iPhone to it, for example in the airport or somewhere else, probably at somewhere else office, it is actually not a charger, not just a USB, but there is a computer inside, and can silently create a backup of your iPhone. Fortunately, with iOS 7, it has been fixed. Well, not fixed. but at least you get a warning that you are connecting not to a charger, but to a computer, and you have to say, do you trust it or not. And last time when I connected my phone to the USB connector in the plane on the transatlantic flight, yeah, I also got this warning, so that wasn't just a charger, and just in case I said don't trust. What is it? What is the story behind the charger? When the computer is connected to the iOS device, and if you press trust, there is a pairing records are being created on both the iPhone or iOS device and the computer, and they're stored. Here are the locations locked down on the PC and on a Mac. And using that record, even if you don't know the passcode, and if your iOS device is protected with a strict passcode, but if you have the access to the parent record, then the computer can get almost the full access to the contents of your device. There is as I said, there is a special service called LockdownD, Diamond, running on the iPhone, and by connecting to it, you can force the device to create a backup. If there is an option to encrypt backups, then the backup will be encrypted. But you can also install the software without the knowledge of the iPhone owner. You can get the device ID and other information. You can sync data between the computer, which is hidden behind, and the iOS device. You can retrieve the screenshot of the device at any given moment, get the diagnostic information, and even put the device into recovery mode. And also you can install the provisioning profile on the iPhone, and all of that will be hidden from you. So take care be careful when connecting your iOS devices to some unknown sources. So here is more information of the advanced logical acquisition using the USB device leap. It is publicly available with the sources and the internet. Just take it and use it and get everything you want. And you get a little bit more than with backup. You can also get some temporary files, cache files, logs, and so on. And please also know that starting from iOS 4, you cannot recover the deleted files like deleted pictures from the iPhone, but you can restore the deleted messages and contacts, because they're all stored in SQLite database, and it is not being compacted on a regular basis, and most of the deleted data can be extracted. The other funny thing about the advanced logical and pair locking is that once you have the pairing records, you can acquire information over Wi-Fi, not only USB. All you need to have is the pairing record itself. That's it. Now let's go to iCloud control panel. If you started on Windows or Mac, it doesn't matter. You will see what information is synced and being uploaded to the iCloud. And in the backup section, you see the list of backups, list of your devices connected to a particular given the Apple ID account with the dates when the backups have been created and their sizes. But basically, that's all you can do there. You can only delete backups, but you cannot download them or browse them and so on. So briefly, how we made a reverse engineering of iCloud backups. Because they're being done only over Wi-Fi, we had to sniff the Wi-Fi traffic, and to be able to read it, it is encrypted, of course. We need to change the certificates on the iPhone, and so we got the jailbroken one and get the keychain from there and replace the certificate. Fortunately, the certificates are not pinned to the device, and so that was relatively easy. And then we set up the Wi-Fi connection proxy, and so we're able to read all the traffic that comes from the iPhone to the iCloud. Also briefly, how the files are stored in the iCloud. That's not only about backups, but also about the documents stored there. They're split it into chunks, which are variable size from very small to large. And the chunks are grouped into containers. And there is also a map of the relationship between the file and the chunks it contains too. What it is being done for, it's just to save the space, because there are a lot of files with some duplicated data. And also iCloud, in contrary with the local backup, it stores as many as 3 last backups. And they're incremental. So only the last changes are being uploaded to the iCloud. And so those 3 backups, they're not 3 full backups are stored there. Only the first backup is full, and for second backup, which is made usually the next day, only the changes are stored, and for the last backup, which is as made today, only the very, very last changes. So typically, for example, if the backup is 10 or 15 gigabytes of data, the second backup is only 100 to 200 megabytes, and the last third backup is only 10, 20 megabytes. But you can create the full free backups using that information. So here is some information about the protocol. First, you have to authenticate using Apple ID and password, and then send a command to called get account settings. Provided the authentication token, which is received on the previous step, and get the new authentication token. I don't know why there are 2, but that's the way how it is being done. Then we send a command using the last authentication token to get the list of backup IDs, and of course you can have more than one device connected to your Apple account, and for every of those devices you can have up to 3 backups. If you interrupt the backup process, you will be able to retrieve information about the latest backup, which is still being uploaded to the server. It just will return an error, but all previous backups are being extracted. And then we have to send a command to get keys, to get, what is that? Backups, the file chunks stored in the iCloud, they're all encrypted. And every chunk, a group of chunks have its own unique encryption keys, but the keys are stored along with the data. And there is a command to get the encryption keys. There are also commands to enumerate snapshots. Snapshots are partial backups there. And for every snapshot, there is a command to get authentication token. And then we send a command to get the an exact address of the every file chunk, and it returns the location where this chunk is stored. And from time to time, in return, you get the link to the Windows Azure via Microsoft Cloud, and some other chunks are stored in on the Amazon. And the part of the we don't know yet exactly whether the half of your backup is stored on Amazon server and the other half is on Microsoft server, or maybe the backups are stored at both locations, and so it's redundant, and you can get the complete backup from for every. I would prefer to have the first way. So, for example, Microsoft alone, without the help of Amazon, will be able to get my complete backup. Here is how the data is encrypted in the cloud. There was some changes from the versions 5 and 6, and in version 7 it has been slightly changed, and in version 7.1 released just a few days ago, there were even more changes. And for most of the files, the two set of encryption keys are being returned, and there is also a flag which of them is being used, and I don't know also the purpose of that, and how the second key is being used. And here is some pseudocode how the IS initialization vector is being generated. There is also a way to get access to iCloud backups and iCloud files without the Apple ID and password. If you have set up an iCloud control panel on your computer, Mac or PC, of course the Apple ID password is not being stored on the computer, but the authentication token does. And there is a way it is stored. Here is at the top there is a location where it is stored in Windows. It is in plist form, easily browsable. And so on Mac it is also stored, and you can from this plist you get the authentication token and skip the first two steps I described about the in the backup retrieval protocol, and just send a comment using the authentication token which is stored there. On Mac the encryption is a little bit better than on Windows, and we have to get the key from the local keychain decrypted with base 64, and then make the digest using the specific fixed key which is stored in one of the libraries, and then decrypt the file using KS128. And here is the code how to decrypt the authentication token. It is only needed for Mac, and Windows it is you get it right now. And using just the crypt protect data from the file I mentioned on the previous slide. And after decryption, using the entropy, which is at the right, it is also hard-coded in one of the libraries. And after decryption, you get the Apple ID, the full name, and the authentication token. It is at the bottom the same as for Windows 1. And but for on a Mac, when trying to get the key from the keychain, you'll get a warning that some application is trying to get the key from there. That's not the real protection, of course, but still. So, brief summary about Apple iCloud backups. As I said, all the data stored in the Apple iCloud is encrypted, but the keys are also stored along with the data, and so Apple and also Microsoft and also Amazon have access to your encrypted data. There are still some files and backups which are further encrypted using the another keyback. This is we see that in the latest versions of iOS, in particular iOS 7.1, more and more information is being encrypted additionally, such as WhatsApp conversations, Viber conversations, and so on. But as I explained, we can also get the encryption keys for this data and get all of them. Yeah. The only thing which is protected most in the Apple iCloud is a keychain. The keychain is encrypted using the specific key, which is unique for every device, and it is not stored in the backup, at least. Maybe it is still stored somewhere in your Apple account, and Apple has access to it, but we cannot confirm this, of course. But if Apple does, then it also has access to your keychain, including your Wi-Fi passwords, passwords to your mail, and so on. And the bad thing about iCloud backups is that you cannot set the additional protection for the backup stored there. With the local backup, once you set a backup password, it is not being it is somehow pinned and stored inside the device. And if you connect the device which is set to create password protected backups to the other computer, you won't be able to create a backup with the other password until you know the original password. You just press the button to create backup, and backup will be created with the same password as originally set. And it is hard to break. It is, I think, 20,000 iterations in the PB-KDF2. And even on the fast GPUs, the speed of recovery only about 100,000 passwords per second, which is not much, and you can break only up to 6 or 7 character passwords. So now go to the iCloud documents. If you go to iCloud.com, you'll see the documents from the Iwork stored there. It's quite convenient to use, and it is being accessible by all of your devices and by Mac, iPad, and iPhone as well. But it is possible to get all of these files not only with the iCloud control panel, but by also reversing the protocol. It has been a bit easier to reverse this protocol because we were able to sniff the traffic between the Mac and iCloud. And first, you also have to do the authentication requests with the Apple ID and password, about the same one as for Apple backups. Then you get account settings as well as with backups also, and then we send a post request, and in return for every file we get its name, the ID, the folder ID, because files can be organized into the folder last change time, checksum, and access rights. And to download any given file from the list we got on the previous step, just we have to first send the request to get the file token using the file ID and checksum and alias map. Alias map is how the file is being stored there. And then send the authorization request that returns information on the file chunks and containers, and the files are stored about the same way as for backups, split it into chunks to save space. For Apple Iwork files, all the data is stored not as a single Iwork file, but as a package. If you log into iCloud.com, you will be able to download every of those files in one of three file formats: in the original Keynote format, in PDF, or in Microsoft compatible format. And the conversion is being done on the server side. And in fact, every file is stored as a plist, and plus a database of all information there. And all the files like pictures and videos are stored separately as separate files. And you can, if you wish, download all these files one by one, if, of course, you know the protocol. Or you can send a command to convert the file. That's an export command, and it is given there. And then you have to send a command check export status and to see whether the file has been converted or not. And once it is converted, you send the other command to download the converted file. With Iwork 2013, which has been released just a couple of months ago, the files can be protected with passwords, and you cannot download protected data from the iCloud, and to get all those files you have to supply the password right on the authentication stage, and we haven't reversed that file yet. And for the local files, for the local Iwork 2013 files stored on the computer, there is a special small file in every package which contains the hash of the password, and the hash is just 100,000 iterations of SHA-1. Now probably about the most interesting part, the iCloud Keychain. It has been introduced in iOS 7, and it is quite convenient to sync all of your passwords and credit card number across your iOS devices and OS X devices. It has been implemented the right way using two-factor authentication. By the way, I forgot to mention that two-factor authentication introduced by Apple about 1 year ago only protects your access to information at the Apple ID, but it doesn't protect from the backup downloading. And once you restore the backup file on the new device, when the restore process is completed, the owner of the Apple ID gets a message by email that some particular device has been restored from this backup using the Apple ID. If you download backup using the protocol you described, has been implemented in our software about 2 years ago, then there is no notification at all, and the owner of the backup doesn't even notice that backup has been downloaded. So two-factor authentication doesn't protect it from that. So that's your choice to select between convenience and privacy. For the Icloud Keychain, it is much better. You have to select the trusted device, which will receive the special code by SMS when Icloud Backup is being used and connected by the other device. You also can optionally select the security code. By default, it is also 4 digits, and by default, Apple offers you to create the same security code as your passcode on the device. I don't know the reason for that. And once you set up the security code, you'll be able to connect to your Icloud Keychain, even if you don't have at this moment access to your trusted device. And this is good. Otherwise, if you, for example, get your iPhone lost or forgotten or broken, and you'll lose access to Icloud Keychain on your iPad, on your Mac, and so on. So here it is. And there is a warning that if there is no other devices available, you can use your cloud security code to connect to the Icloud Keychain. That's how it works on Mac. It seems that Icloud Keychain contains more information than the local keychain. I have been surprised by that once I have connected, but probably that's because once I set up the Icloud Keychain, it has collected all the information from all of my iOS devices, and I have, I think, 5 or 6. Some of them are being used for testing our software, some of them are for work, and also from Mac. And also before the enabling the Icloud Keychain, I haven't seen my Apple ID password anywhere there, but now it is available, and I can see it in the Icloud Keychain. And once you set up the trusted device, and when connecting the new device to it, it prompts for the security code, or if you don't have access to a trusted device, or if you do, you'll have to enter the verification code, which is sent by SMS message to your other device. And also on the other devices, you'll see the warning that whether to allow the new device to connect to this Icloud Keychain. And even if you know the verification code and security code, but say don't allow, then the Icloud Keychain will be connected. Here is the warning at the bottom shown on the iPad when I try to connect the new iPhone to the Icloud Keychain. Here are the components of how Icloud Keychain is working. It accesses the keychain database, which is stored locally, and there are some drivers here. They're working on the Mac. And here is the description of the components. There is a process remote service which interacts with iCloud control panel. Then there is a SBD daemon, which is caching and restoring the keychain, and also it receives the notification on the iCloud Keychain updates when the updates are happening on the other devices. Then the Apple service is sending notifications to all the devices this keychain is set up on. There is also the Lucky2 daemon, which communicates with iCloud, gets requests, make queries, and decrypt the responses, and as well as the SecD security daemon, caching and restoring the keychain, and also getting notification. And then the low-level Apple OS X driver, and the security framework is just being used for the encryption and decryption functions. To get the keychain, first we have to send the get account settings. using the Apple ID and password, and as always we get the authentication token in return. It's quite similar in all the Apple components, from backups to Apple iCloud files, and also Find My Phone service, and about the same for Icloud Keychain. Then we have to send a sync command to get the keychain itself and keyback. At this step, we don't need the security code or the code sent to the trusted device or whatever else. We always can get the keychain and the keyback, and but of course all that is encrypted. The keychain itself is encrypted using the key stored and the keyback, and the keyback itself is also encrypted. Here is the response into the sync command to get the keychain and keyback, and we have the data in base 64 to get all this data. But then we have to check whether this account needs the SMS challenge to be sent. There is another command for that, and it's called get SMS targets, and if the SMS challenge response is required, then we receive the enroll requires phone number key, and then we will have to send another command called generate SMS challenge, and at this step the trusted device will get the notification, and in return to this query we receive the length of the response, which have to be entered and supplied on the next step. Here is the get keyback key. This key is being used to encrypt or to decrypt the keyback, and the keyback is being used to decrypt the keychain. And at this step, if the SMS challenge response is required, we have to supply it, obviously. And in return, we receive the base 64 encrypted data. Here is also the get keyback key, and so in fact this is keyback recovery as well. Interestingly, that as for backups, when we're using the same protocol as Apple seems to use, we also don't receive the prompt on the other devices whether to allow the new device to connect to this keychain, and I don't know why. It happens all the time when you connect to the keychain manually, as described by Apple, but if we're using those commands, then there is no notification on the other devices, and so you can also silently connect. And if there is a security code and you don't know it, then you only need to know the Apple ID and password and the security code to extract and decrypt the keychain. Here is how the keychain data is encrypted. There are two types of keychain data. One is the GenP, like generic class, which is used to Wi-Fi passwords, to access points, and for credit card data. And the second class is INET, Internet class, used for Safari passwords and autocomplete fields, which are also being used for passwords. Now the structure is quite simple. There is a key class, a version, data size, and data itself. And the algorithm to generate the key to decrypt this data is also not really hard. Fortunately, the thing that has been implemented right, that there is no way to brute force the security code if you know the Apple ID and password, and after a few unsuccessful attempts, the access to Icloud Keychain will be blocked. For Apple ID passwords, the situation is a little bit strange. If you go to iCloud.com and enter incorrect passwords a few times, your account will be blocked pretty fast, about after 5 to 7 incorrect enters of the password. But if you use also the reversed protocol to access the iCloud. At least we tried that about 50 times, and the account hasn't been blocked. And so probably there is a way to brute force the Apple ID password. Of course, there is not still not very reliable, and I'm sure that after some amount the access will be still blocked, and also the verification is not so fast. But probably you can use brute forcing for the to retrieve some short and simple passwords. And also, it is possible to implement the other attack using the one single password and different Apple IDs. So in that case, of course, access will be blocked, but once you have collected many Apple IDs, which are just the emails, probably the passwords will work with at least some of them. So, the conclusion on the Apple iCloud security. There is always a balance between the security, privacy, and convenience, and you have to select yourself which is best to you. I have lost my phone and forget it in some places, and it has been stolen a few times, and I have the 9th or 10th iPhone, I don't remember. And once it happens at the first time, 2 years ago, I immediately decided to use the iCloud, and then it really helped me because I just got a new device, and in 2 hours I got all the information back on my phone, including all the call logs, messages, and everything. But there is a security risk because you know that now you know that the data is stored on the third-party service, not at the Apple ones, and Apple has almost complete access to all of your data. And probably also need better two-factor authentication, and probably an ability to encrypt your iCloud backups and your iCloud documents using your own password or your own encryption key. There is a lot of work ahead. We don't know how the access to photo streams are being done and what kind of authentication is to be used there. There is quite a lot of work with third-party application data. Most of them are encrypted, as I said, using the over-the-air keyback, and we can now decrypt them. But some applications are storing the data some other way, that their own. And we have to take care about back to my Mac to reverse the protocol being used there, and probably the most interesting part is to understand what is going on with Touch ID and what kind of information is stored there. Now very briefly about Blackberry backups. It is completely different from Apple iCloud backups and Apple local backups. With the old version of Blackberries, the backups were similar to local iTunes backups, but there was just one single files, and you have to supply manually the password to it. And with version 5, the password checking function was quite simple. That's only just one iteration in the PBKDA function. And so the brute force and dictionary attacks were extremely fast at millions of passwords per second. But shortly after we discovered that and released the software to break the Blackberry backups, RIM, at that time it was RIM, not Blackberry, released the new version of the Blackberry desktop software and added as many as 20,000 iterations of SHA-1, like with iPhone backups. But still there is a way to use the GPUs to make it faster. And old files had very simple file format, and with the
Ja, bitte. Ja. DisplayPort Adapter auf, VGA? Nee, alle verballert. Ich weiß auch gar nicht mehr. Der hängt da drin, ne? Die Striemen da, ja. Ja, die sind. Für den Hans Buschbach mache ich das hier. Ich hoffe, das reicht jetzt und der hat eingepegelt da drin im Audit. Dann kann ich das für später hier draußen benutzen. Mal gucken. Michael?
Okay, and once BlackBerry released the the tablet playbook, it has introduced the new backup format, and the operating system BlackBerry 10 is also completely new, and the backup is based on the QNX, the operating system of BlackBerry, and now the tar files are being created, and the software is also new. It is BlackBerry.
Hallo. Reicht oder ist gut? Test. Yeah.
And once the BlackBerry link with the support of BlackBerry 10 operating system and devices has been made available, we have found that there is no way to set the password to BlackBerry Backup, absolutely. There is no such option in the software, but the backup itself is always encrypted. And all you can do with this backup is like with Apple Backup, you can only restore the new device to it. And also, before restoring, you have to set up the new device with the same BlackBerry ID and obviously the password. And here is why. Here is how we have explored it and what are the components. There are, as a BlackBerry 10 operating system is based on QNX, we just get this information and mounted the QNX partition on the Unix system. And we have found that encryption is based on IS 256, and verification is based on HMAC SHA-1. And the main component to create backups is backup arch inside a backup CGI program running on the BlackBerry. And like with Apple iOS, this daemon working right on the device is giving the BlackBerry link already the encrypted contents, and so all the encryption and decryption is being done right on the device. And the encryption key is probably the most interesting part, that the key is stored in a special partition on the device itself. It is generated at the time when you set up the new device to set the BlackBerry ID, and you authenticate with the BlackBerry ID password. And in return, the BlackBerry services are returning this encryption key, which is probably the most like the actual ID of the BlackBerry device. And this ID is being sent to the device itself, stored there, and then backup service is using it to encrypt the data when you create the backup, and also to decrypt the data if you restore the device from the backup. It is called the first component which is being used is a BlackBerry token service. We send the request using the BlackBerry ID, the password, the PIN. The PIN is a unique ID, also the device using for BlackBerry messengers and so on. And this PIN, it seems that it doesn't take part in the encryption and in the generation of the encryption key, but you can provide any PIN, any valid PIN to the server and get back the encryption key, and it doesn't rely on it. But if you supply the incorrect PIN, which is not registered somewhere on BlackBerry service, then you will fail. So here is the query which is being sent using the BlackBerry ID, which is email, password, and some other information. And then to get the key back is the encryption key. Here is the sequence of steps to be performed. First, we get the one authentication token based on the query described on the last step. Then we get the other token using information returned by the previous query, and then we send the request to the other BlackBerry service, and then we register the device on the BlackBerry service. So I should say that was a real nightmare to reverse all these protocols, because about 6 or 7 different servers and services using by BlackBerry to finally get this encryption key. And as I noted above, that the Quebec seems to depend only on BlackBerry ID on the email, and of course, if you change the password to the BlackBerry ID, the encryption key is not being changed, and also you have to supply the valid PIN to get it. So here is how it works. I don't know why it is called Olympia. It's not an official name, and you probably won't get any information by Googling for it, BlackBerry Olympia, but that's an internal name which is being returned by some of the queries. And the key, once received, is being stored on a special area on the BlackBerry device and then used by Scrambler. And Scrambler component is encrypting and decrypting the data and send it to the backup service. And so BlackBerry Link, like the iTunes, only collects the encrypted information and writes it to the file. Briefly, what is inside the BlackBerry backup, BlackBerry 10 backup, once you have it decrypted? Of course, there are calendars, contacts, all the messengers in the plain unencrypted form, both SMS messages and BlackBerry Messenger. There is also Facebook databases with all the conversations and of Facebook Messenger, and there is the other database which collects all the notifications about the comments on your posts and so on. There is a different database for BlackBerry messengers and messages themselves, and also the groups and contacts. And WhatsApp database is also in a plain text form. In the previous versions it was encrypted, and encrypted really good, based on the hardware key which can be extracted from the device only using the chip-off method. And now you can get all the WhatsApp, which is most popular messengers being used between different platforms. The second archive, media.tar, it contains all the pictures and medias and voicemail as well. And third archive, settings.tar, contains all the settings of the device and also all the passwords to Wi-Fi access points and to VPN networks in a plain text form. And you also get all your bookmarks used in browsers, map data, and so on. So almost everything is stored in BlackBerry backups in plist files, and also on SQLite databases, like with Windows Phone and Apple iPhone, and also Android. Yeah. Yeah, that's it. I only wanted to say thanks to my colleagues, which have been working hard under that. For BlackBerry, for example, it took more than 6 months to go inside BlackBerry protocols and to reverse everything. With Apple, we're still working on it. The hardest part was Windows backups, and then everything was a bit simpler with other services. So that's it. Thank you.